This is one small AVR programmer with 3 different firmware choices: AVR910, STK500v1, and STK500v2. The AVR910 version was created by me, while the 2 STK500 versions were developed with help from a top AI assistant. Every version has been repeatedly reviewed and tested on real hardware. This board can also reprogram itself. The same USB cable is used to install a different programmer firmware and then program an external AVR microcontroller. Switching between protocols is quick, simple, and does not require another programmer. It is also extremely fast. The best results reach more than 28 kilobytes per second writing and more than 33 kilobytes per second reading. That speed reduces waiting during every upload and can save a serious developer many hours over time. The RGB LED makes the whole process easy to understand. Purple means writing, cyan means reading or verification, white means chip erase, and 2 green flashes mean the operation completed successfully. Most inexpensive AVR programmers give you 1 fixed firmware and 1 fixed experience. This board gives you 3 programmer protocols on the same hardware. The AVR910 firmware is my original creation. It has been developed and optimized through extensive real-world testing. This is currently the fastest writing firmware of the 3, reaching approximately 28.3 kilobytes per second under the best test conditions. The STK500v1 firmware provides another strong option. In my testing, it reached approximately 25.6 kilobytes per second writing and 33.4 kilobytes per second reading. It gives excellent overall performance and currently has the fastest reading result among the 3 versions. The STK500v2 firmware provides compatibility with the newer STK500 version 2 protocol. It has also been tested on the actual board and reached more than 20 kilobytes per second writing and more than 31 kilobytes per second reading. You are not locked into only one of them. You can try all 3, compare them, and choose the one that works best for your computer, your AVR target, and your own workflow. The firmware packages are provided separately so the board can continue to improve without replacing the hardware. The self-programmable design is what makes this possible. Inside the board is my own FDxICSP bootloader. It allows the programmer firmware to be replaced directly through the USB connection. To change protocols, connect the board to the computer, reset it into bootloader mode, and upload the selected firmware. After that, the board is ready to program an external AVR through the 6-pin ISP connector. The same USB cable does both jobs. You do not need to remove the programmer chip. You do not need to buy another programmer just to update this one. You do not need several different boards taking up space on your desk. One board can become an AVR910 programmer, an STK500v1 programmer, or an STK500v2 programmer whenever you need it. This also makes the product more future-proof. The hardware is not limited to the firmware installed on the day you receive it. New firmware improvements and additional protocols can be installed later. Speed is another major advantage. During AVR development, code is rarely uploaded only once. A project may require dozens, hundreds, or even thousands of uploads while testing, correcting, and improving the program. A slow programmer adds another delay after every compilation. One delay may not seem important, but repeated delays become hours of wasted time. A faster programmer makes development feel more immediate. You compile, upload, test, and continue working without constantly waiting for a slow transfer to finish. The difference becomes even more noticeable on larger AVR devices and larger program files. This board has been tested with devices including the ATmega16, ATmega88P, ATmega128, and other classic SPI programmable AVR microcontrollers. It supports flash, EEPROM, signature bytes, fuse bytes, lock bits, calibration data, and chip erase operations. It also supports a wide range of target clock speeds. That makes it useful for both normal AVR boards and targets running from unusually slow clocks. The board includes selectable 5-volt and 3-volt operation, a standard 6-pin AVR ISP connection, USB to serial communication through the CH340G, a reset button, and a large RGB status LED. The LED is not there only for appearance. When the programmer is ready, it gives a brief purple pulse followed by a longer blue period. During writing, the LED appears purple. During reading or verification, it appears cyan. During chip erase, it appears white. After a successful operation, it flashes green twice. This gives immediate feedback even when the computer screen is not directly in front of you. You can see whether the board is waiting, writing, reading, erasing, or finished. The blue part of the LED is also connected to the actual programming clock, so its activity reflects real communication with the target. The board is compact, self-programmable, fast, and flexible. Instead of buying separate programmers for different protocols, you get one platform that can change with a firmware update. You can use the AVR910 version for its excellent writing performance, STK500v1 for its strong overall speed, or STK500v2 when that protocol is preferred. All three firmware versions have been repeatedly checked and tested, and the project continues to be improved. For AVR development, this means less waiting, fewer separate tools, easier firmware changes, and a clear visual display of every programming operation. 1 USB cable, 3 programmer protocols, high transfer speed, 1 small board.